Blood plasma within the bloodstream contains many clotting factors that come together with tissue factor and platelet factor 3 to enable blood clotting, or coagulation. There is a clotting factor called factor V. Its factor name is proacelerin. Factor V takes part in the third step of blood clotting, coagulation. When factor V is activated, it interacts with another clotting protein called factor X to make up two complexes called factor Xa and factor VA. This complex, along with calcium ions and platelet factor 3, forms prothrombin activator. Prothrombin activator catalyzes the transformation of prothrombin into thrombin. Thrombin then goes on to catalyze the conversion of fibrinogen into fibrin, which makes up the fibrin mesh in blood clots. After a blood clot occurs, the normal flow of blood washes out clotting factors. The body also prevents clots from continuing to grow by restricting thrombin to the clot and keeping it on the fibrin threads. Heparin, the body's natural anticoagulant, inhibits thrombin by enhancing the activity of antithrombin 3. Plasma protein antithrombin 3 works to inactivate any thrombin that is not bound to fibrin. Antithrombin 3 also works with activated protein C to decrease the activity of clotting factors found in the blood, including factor V.
Hi, I'm factor V, and I'm here to make this fibrin mesh.
Hey factor V, my name's activated protein C. Whoa, that clot's getting a little too big. It's time for you to go home.
Alright.
See ya.
Bye.
In the case of factor V Leiden, a mutation within the factor V gene causes the protein to be more resistant to the effects of APC. APC's anti-clotting proteins are kept from breaking down factor V. This makes APC's anti-clotting actions take a lot longer than normal. This condition is called APC resistance. Factor V, that clot is getting way too big. You need to stop. It's time to go.
Nah, I'd rather just stay here and keep making this clot bigger when I know I'm not supposed to.
No, seriously, it needs to stop. You need to go home.
No, I got it.
Why is this happening? Normally you leave. It's like you're mutated or something. Stop! Go home, factor V.
No!
No more.
No!
Do you see this is getting out of control? It could turn into a deep venous clot. Factor V, leave. Stop. Alright, no. You need to go.
Fine.
Finally, that took a really long time. Here we are able to see that APC binds to the binding site on factor V and is able to cleave it into two inactive fragments. But here with the factor V Leiden mutation, you can see that the shape of the binding site on factor V has changed. APC now takes a lot longer to inactivate factor V Leiden. Although a person could have factor V Leiden and not necessarily be affected by abnormal blood clotting, factor V Leiden poses a higher risk of developing deep vein thrombosis. Deep vein thrombosis is a blood clot that occurs in a deep vein, typically in the legs, but can also occur in the eyes, brain, and liver. Which leads us to discuss one of the biggest risks of factor V Leiden. If a DVT breaks off and goes into the general circulation, into the inferior vena cava, up to the right atrium, down to the right ventricle, into the pulmonary trunk, that clot can get stuck in the lungs and disrupt blood flow. This life-threatening condition is known as a pulmonary embolism. People who have had a deep vein thrombus or a pulmonary embolism are typically treated with anticoagulants. Anticoagulants used to treat factor V Leiden include warfarin and heparin. Warfarin is a long-term anticoagulant pill that lengthens the time it takes to form a clot. Warfarin works by blocking the effects of vitamin K. Vitamin K is used by the liver to make enzymes needed for blood clotting. Heparin is found on the surface of endothelial cells and within basophil and mast cell granules. It's the body's natural anticoagulant, but it can also be given to people with factor V Leiden. What heparin does is it enhances the activity of plasma protein antithrombin 3, whose job is to inactivate any thrombin that is not bound to fibrin. By inhibiting thrombin, the clotting cascade is finally stopped. There are two types of heparin. There's unfractioned heparin, and the most common type of heparin is called low molecular weight heparin, which can be administered at home by an injection.